Okay. So, solving trig equations, and we're just going to jump right in because it's solving equations, and that's something you guys have been doing for, you know, several years now. So, solve for, we'll say solve for x. Okay. And we'll say assume 0 is less than or equal to x is less than 2 pi. Okay, kind of start out there. Okay. So, let's say we've got 2 sine of x plus 1 equals 0. And so to solve for x here, we want to get to x by itself, or at least get down to the trig function here, sine of x. So we want to get that, we want to isolate, okay, the trig function. And all these equations are going to have our variables inside of a trig function. All of our equations that we're working on will have the variable inside the trig function. So here we go. That's what we're going to do. Isolate the trig function. That's the basic goal here. So we'll subtract 1 from both sides. Divide through by 2. And sine of x equals negative 1/2. Okay. And so then we want to know when does sine of x equal negative 1/2. For what radian measures does sine of x equal negative 1/2. So again, if that's troublesome to you, if you're like, I'm not really sure how to figure that out, well, some options. You can go to your reference triangles, for example. That's one way to do it. Okay, so I'll redraw these here. Okay, so we have our 30, 60, 90, or pi over 3, pi over 6, pi over 2. And then we've got our 45, 45, 90. Okay, like that. And if I want sine to give me 1/2, I'll forget about the negative right now. Let's just figure out sine to give me 1/2. Well, that means I need the opposite to be 1, the hypotenuse to be 2. So let's see here. If I say just pi over 3 opposite of that is root 3 over the hypotenuse of 2, so that's not right. So it must be the pi over 6, right? Opposite is 1 over 2. So then pi over 6 is our reference angle, but we need the angles that are have a pi over 6 reference angle that are negative. So again, we can go to our different quadrants here. And so we need the pi over 6 angle from quadrant 3 and quadrant 4, right? That's where sine will be negative. Here, all trig functions are positive. Here, sine is positive. So we want the pi over 6 angle in quadrants 3 and quadrant 4. So that would be 7 pi over 6. And that would be 11 pi over 6. And there are the two answers, okay, to that equation. Again, we're sticking with just x values between 0 and 2 pi. Really, there's an infinite number of answers, okay? If I didn't have this limit in here, so if I just said solve for x, what could I do with this 7 pi over 6 or 11 pi over 6? What could I do to those two numbers to get additional answers that would also solve this equation? What could we do to 7 pi over 6, for example? What could we do? Add or subtract 2 pi. Exactly right, Anna, okay? Same thing with the 11 pi over 6. Add or subtract 2 pi. Okay, so if I were to eliminate that, the limitation there, we could just add or subtract 2 pi to get more coterminal angles. Remember, coterminal angles are in the same position. So adding 2 pi to 7 pi over 6 would result in an angle that's in the same position and therefore would have the same ratio. Okay, so exactly right. All right, let's try another one here. Sine of x plus the square root of 2 equals negative sine of x. Okay, Good morning, sir. How are you? Trig equation. Nah. Remember, you did imaginary stuff. I did not. Oh, well.
Have you already graphed everything?
Thank you. Yes, we did graph. Yes, yeah, right.
Alright, well, someday.
It's okay. You'll get there. We'll all get there. Yeah. Thank you.
Enjoy.
Always.
I screwed them up. The non-calculator is the last page.
Oh, so you gotta tear that off? Gotcha.
Okay, sorry.
Okay, not a problem. Alright, so back to this. There's the equation. Alright. Now, here we've got sine on both sides. So any ideas? What should we do here to solve this? What do you think? Sine on both sides. Well, let's get those signs together. Right? When you have variables on both sides, you want to get those variables together on one side, right? Either get them all to the left-hand side, all to the right-hand side. So here I'm going to move everything over. And so let's see here. Negative sine of x plus sine of x cancels out. We're left with just 0 there. Sine of x plus sine of x, what's that going to be? 2. Right, if I have 1 sine of x and I add a sine of x, I now have 2 sine of x. Okay. Equals that. Which now we can be, oh, okay, well, we'll subtract root 2 from both sides. Right. And then divide by 2. Sine of x equals negative root 2 over 2. Oh, thank goodness, that's one of the ratios that we have. Okay. So that's the pi over 4. Okay, that's going to be pi over 4. Sine of pi over 4 is 1 over root 2, right? But remember, 1 over root 2 is the same thing when you rationalize it as root 2 over 2. So root 2 over 2 there. Okay, and so we need the pi over 4 angles, but we need the pi over 4 angles where sine will give us a negative ratio. So again, we're talking about sine. So not in the first quadrant, not in the second quadrant, right? So we want the third quadrant pi over 4. We want the fourth quadrant pi over 4. So third quadrant pi over 4, 5 pi over 4. And then fourth quadrant pi over 4, 7 pi over 4. Okay. And again, since we're still sticking to be between just 0 and 2 pi, right? We're kind of still following these directions from earlier. All right. Then we only would include 5 pi over 4, 7 pi over 4. If we wanted more solutions than that, right? If we wanted to like indicate the infinite answers that we could have, if we didn't have that restriction between 0 and 2 pi, then we would just add 2 pi to 5 pi over 4, subtract 2 pi. Same thing with 7 pi over 4. Add or subtract 2 pi. Okay. We'll try one more here, and then I'll have you all try one on your own. Okay, we'll do one more here. We'll do one with tangent. Alright, so again, we'll solve for, this time I'm going to say solve for theta from 0 to 2 pi, 0 included, 2 pi excluded. Okay. Okay, so now I've got 3 tangent squared of theta minus 1 equals 0. Okay, and let's see, let's go to someone, Madison. Madison, how should we go about solving this trig equation here? What do you say? Isolate the trig. Okay, so what would I need to do that here? Add 1, divide by 3. Okay, I'm going to do that all at once. Tangent squared of theta equals 1/3. Anything else we should do here? So we have tangent squared of theta. Yes, square root both sides, exactly right. Okay. Tangent squared of theta. Remember, when you see tangent squared of theta, this is the normal way of writing the quantity tangent theta squared, like that. Okay, these two things are equivalent. For whatever reason, put the 2 in between the tangent and the theta like that to show, you know, that tangent of theta is being squared. Which, again, is really strange when I then say that tangent right? That really makes it confusing, but that's the way it's written. Okay? Remember, tangent -1 theta, that means tangent inverse. Or the arctan, okay, of theta, right? Tangent of theta to the -1, you'd see it written like that. Okay, but here they are the same thing. Tangent squared of theta is tangent of theta quantity squared. Just a little aside there. All right, great. So that means we have this. Oh, and when we do an equation setting, we're square rooting both sides. We really need to have a plus or minus there in front. So it's going to be tangent of theta equals plus or minus. And the square root of 1 is 1, square root of 3 is square root of 3. Okay. So now, we could rationalize this, but actually if you go back to up to our reference triangle here, what angle theta, Madison, is going to give us, and when you do tangent of that theta, is going to give us 1 over root 3. Pi over 6, yeah. So theta is pi over 6. But then since we want it to be both the positive and negative 1 over root 3, which by the way is the same thing as plus or minus the square root of 3 over 3, right? For those of you that maybe were thinking that's unfamiliar, right? If you rationalize this, plus or minus root 3 over 3. Pi over 6 works, but then so will 5 pi over 6. Okay, because that'll give us negative 1 over root 3. And then so will 7 pi over 6 in the third quadrant, because that'll give us another positive 1 over square root of 3. And then so will 11 pi over 6. So it's all 4 quadrants, because you have both positive 1 over root 3 and the negative 1 over root 3 there. So it's 4 answers. 4 answers. All 4 will work. Okay, all 4 work there. All right, questions on any of that? Ready to try one on our own? I'll take your silence as a yes. Okay, so here we go. So y'all try this one here. Again, same directions. Solve -3 secant squared of theta plus 3 equals -1 for theta, and again from 0 to 2 pi. Let's go ahead and try and solve that. Solve -3 times the secant squared of theta plus 3 equals -1 for theta for 0 to 2 pi. Oh, really? Let me see what you got. Don't forget though, that was a negative 3. Okay, so then what value of theta give you that? And remember folks, if secant of theta is uncomfortable for you, right, you get down to like secant of theta by itself, right, secant of theta equals something, and you're like, secant you're not so comfortable with, just reciprocal, right? What's the reciprocal of secant? It'll be cosine. So secant of theta equals something, and do the reciprocal of both sides, and evaluate the cosine of whatever that reciprocal is. Okay. So you did reciprocal of that, means you might reciprocate this too, so it should be then 3 over 4. You can do it like that, yeah, it'll kind of work like that still, yeah. So then break it up then, right? So make it, instead of square root of 3 over 4, make it square root of 3 over the square root of 4, and then oh, good, thank you. Okay, so so rather than rationalizing, let's talk about it being just 2 over the square root of 3, right? So secant is hypotenuse over adjacent shot, choke shot, so hypotenuse. So you said your triangles. 30 should be here, 50 should be here. Yeah. The easiest way to remember, because I always would do that too, the easiest way to remember is that the third you always have to be the smallest angle, always has to be the opposite of the smallest side. 1 is less than the square root of 3. Oh, you did it again. All right. There should be your answers. Okay. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. So, you know, I subtracted 3, so it gives us negative 4, divide over the negative 3, so it's negative 4 over negative 3, making it positive 4/3, equals secant squared theta. Square root both sides, you're going to get plus or minus. Okay? That simplifies. So, square root of 4 over 3 is the same thing as the square root of 4 over the square root of 3. So you can break up a square root over division. Not subtraction, not addition, but you can break a square root up over division and multiplication. So it gives us 2 over the square root of 3, which then, rather than rationalizing this, I did the reciprocal to make it cosine. When does that equal root 3 over 2? Which you can do that. Okay? I think it's more familiar, right? We're talking about sine, cosine, and tangent. So then it's the 4 answers to get the plus or minus there. Any questions on any of that about where I got anything or why I knew what to do? How did I evaluate cosine of theta equals root 3 over 2? We're all good with that? And just use those reference triangles to help you too. All right. All right. I got 2 more here I want to show, and then we'll move on. Okay. And then we'll be done. All right. So again, same directions here. Just a different kind of problem. Okay, here's our next one. Next to last one. Okay, so we'll do one more after this. So, what we do not want to do here is divide both sides by cosine of theta. Okay? What we do not want to do here is divide both sides by cosine of theta. And it's for the same kind of reason as, if you remember, like way back towards the beginning of this class, if we had a problem like this, where it was like x squared equals x, it's for the same kind of reason why we don't want to divide both sides by x here. The reason why we technically are not allowed to divide both sides by x here is because we don't know what the value of x is. If x is 0, dividing both sides by x would be dividing both sides by 0, and you can't divide by 0, right? It's undefined. So we don't divide by 0. So how would we solve a problem like this? Well, you would subtract x on both sides, and then factor. And then you would set each factor equal to 0 there, and you would in fact get that x is 0, and then also x is 1. Alright. And so it's dangerous to divide both sides by x values. For that same kind of argument that we have here, we also don't want to divide both sides by cosine here, because can cosine equal 0? Yes, it can. And so we don't want to divide both sides by cosine because we could be dividing by 0. So how do we fix it? The same way we did here. We'll have cosine theta sine squared theta minus 2 cosine theta. We'll subtract it from both sides and then equals 0. Okay. And then how should we proceed from here? What should be our next step? What can we do here? What do we have in common between these two terms here? Nick?
Can you combine the cosine? Would it be like negative cosine of theta?
So let's see here. You want to subtract these two things? Is what you're saying?
Yeah.
Okay. So are they like terms? This term is cosine theta sine squared theta. This term is 2 cosine theta. Are they like terms? So they're not like terms. We can't subtract them, but what can we do here? Factor out the cosine. Exactly right, yeah. Factor it out. Leaving behind sine squared theta minus 2, and again equals 0. And now we have two things that are multiplying together and they equal 0. So we can use that zero product property. If two or more things multiply together to give us 0, that means one of those two things, either cosine of theta is 0 or the sine squared of theta can be 0. Okay. Cosine of theta is 0 when theta is what? When is cosine 0? So that's not a reference triangle. Pi over 2 and 3 pi over 2. Yeah, both. So pi over 2 and 3 pi over 2. Very good. And then this other one here, we have some work to do. We'll add 2 to both sides there. And then we'll square root both sides. And when I square root of 2, it's really plus or minus the square root of 2 there. Okay, great. And so when does sine of theta equal the square root of 2? When does sine of theta equal the square root of 2? Or the negative square root of 2? And this is kind of mean of me, because it never equals the square root of 2. Okay. What's the highest value that sine can reach? Sine just by itself. What's the highest value of sine that we can have? 1. 1 is smaller than square root of 2. The lowest value you can reach, negative 1, right? Negative 1 is, negative root 2 is further away than that negative 1. Okay, so both those things are, you can't equal it. Okay, root 2 is bigger than 1, so it's impossible. So it's just pi over 2 and 3 pi over 2 that are solutions there. Okay? So let's do one more here. And let's say secant squared theta tangent squared theta minus secant squared theta equals 0. Secant squared theta tangent squared theta minus secant squared theta equals 0. Okay, and again, theta is in the interval 0 to 2 pi. So it's very similar to the one we just did. All right. Zach, any ideas here about how we should start this? No idea? Okay. Well, let me give you a little help here. So what do you see in common between these? So we have two terms, right? Secant squared theta, tangent squared theta is one term, minus secant squared theta. Do you see anything in common between those two terms? What's that? They're all squared. What about common things, common values in those two terms? Something in common to both. Just like up here, right, where we had cosine times sine squared theta minus 2 cosine theta, they both had a cosine, right? We were able to factor out a cosine. Can you do that here with anything?
Yes, you did.
The secant squared, right? So factor out a secant squared. If I factor that secant squared out from here, Zach, what's left over? Tangent squared. And if I factor out of here, what's left?
Theta, 0.
Not 0, 1, right? When we factor, we're really dividing. So when you divide secant squared theta out, you're dividing by a secant squared theta, so you're left with just a 1 there behind. And so it equals that 0. And so now we can set each thing equal to 0. Okay. All right. And so we can square root both sides here of that secant squared theta. We're going to end up with the secant of theta equals 0, which again I'm not very familiar with, but if we reciprocal both sides, the reciprocal of secant's cosine, and reciprocal of 0 is undefined. Okay, so when is cosine undefined? When is cosine undefined? I'll take your silence as never, and that's correct. It's never, never, okay? It's an impossible question. Cosine's never undefined, okay? Cosine's never undefined. All right, and then tan squared theta minus 1 equals 0. All right, we'll add the 1 over. Square root both sides. Tangent theta equals plus or minus 1 then. Go back to our reference triangles here. When does tangent theta equal plus or minus root 1? Remember, tangent is opposite over adjacent. So let's just try pi over 6. Let's see, opposite pi over 6 is 1 over the square root of 3. That's not equal to 1. Let's try pi over 3. Opposite root 3 over 1. That's not equal to 1. Let's try over here. Pi over 4. Opposite 1 over adjacent 1. That's it. Pi over 4. But all the pi over 4s, because it's plus or minus 1. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And those are our answers. Okay. The secant squared root there, that gave us a dead end, right? But this product can still equal 0 if these theta values are equal to pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, because this will then result in a 0, and 0 times anything over here will still be 0. Okay? Questions on any of that? All right, then let me give you guys something to practice this, okay? And I would really like you guys to try these problems because I think we need to work with these sums, okay? And then while you're working on these problems, I'll come around and also collect your warm-ups too. So if you want to get your warm-ups out and then get started on these problems, get a good 20 minutes here to get some work done, according to that clock. So I would like you to really get started on this. Okay. So page 394, numbers 11 to 19, 25 and 27, and those are all odds. Okay, so 11 to 19, 25 and 27, the odds. So that's 7 problems. Okay, 7 problems.